You've probably seen all the hype now. And what's even better is that we have George Andrianakis, and I sure hope I said that right, here to talk about all the great upstream work being done in Quarkus and what's new, what's coming up, and how that relates to Kubernetes. And thank you so much for joining us, George. Go ahead and take it away.
Thanks a lot, Karina. First of all, the pronunciation was great. So I'm George, or Georgios and Thomas. Thanks very much for having me here. So yeah, like you said, we'll be talking about Quarkus today. We also have Thomas here with us, who's a Quarkus PM. He'll be able to answer a ton of your questions. So I guess I'll get going with the presentation, and I'll try to do a quick demo as well, and then we could get into questions. So first of all, real quick, who am I? My name is Georgios and Thomas, like earlier. I'm an engineer here at Red Hat. I've been working on Quarkus, brain stuff, so exciting Java technologies. I'm also a speaker at various conferences and stuff, and as relates to Kubernetes, I'm also co-organizer of the Athens Kubernetes meetup. So let's get started. What is Quarkus? The way we see Quarkus, basically, we see it as an open source stack or framework, you could say, to write your Java applications. And we're not just talking about like any applications, right? The applications we really see Quarkus being a great fit for are applications that target cloud native architectures, microservices, or even serverless that we see a lot these days. What that means is that, like, although you can use Quarkus to write your traditional monolithic application and run on gigantic application servers, that will work, and you will see a lot of benefits if you do that, if you use Quarkus instead of something else. But the problems we've really tried to address, and our main focus is on modern architectures, like trying to solve problems that you'll encounter when you try to deploy to, say, Kubernetes or OpenShift, and problems that you will encounter when you have like a lot of microservices trying to communicate all with each other when they comprise your whole architecture. So why did we do Quarkus? Basically, that's a question that comes up a lot, because in the Java space, there's a lot of frameworks to do enterprise Java development, right? So there's a question that comes up like, why did you do Quarkus, and why is it so different than all this other stuff that's out there? Basically, the basic principle is that we have to think that like circa, let's say, I don't know, 2014 or something, we started seeing this move from big monolithic applications where Java was like really prominent for huge monolithic applications, we saw this move to new architectures where these big monolithic applications are being broken down into small microservices. Or when you take that to the extreme, we're seeing our application architectures being broken down into tiny, let's say, functions, where each deployment does a very, very specific thing, and it's very, very small. And that solves a lot of problems, obviously creates more. But for a lot of teams, we saw that this breakdown, let's say, architecture, gave them a lot more agility. But I would say that Java suffered maybe more than other platforms from this move because of a very simple fact. The fact was that Java, as a managed runtime, wasn't really, the focus was never really on fast startup and consuming a little memory. Java's focus from like the end of the previous millennium up until a few years ago was always to gain the maximum throughput for an application at the expense of memory. So what that means is that when you have a lot of Java applications, as we see in this slide here, the useful memory for your Java application, let's say the useful memory as an application developer consume is the memory on the right, this Java heap memory. But that means that the percentage of the heap memory is sort of small when you're breaking up a big application into a lot of small applications. You're wasting a lot of memory on this, let's say, metadata that the JVM consumes. So the JVM uses up a lot of memory in order to achieve this great throughput that it has. And as an application developer, when you're deploying a huge, let's say, monolithic application, let's say ran on like 10 gigabyte of RAM, this extra metadata, let's call it metadata RAM, that was taken up, let's say it was maybe 200, 300 megabyte, it didn't really matter because it was a really small fraction. But when you're deploying microservices, let's say each instance of a microservice to take up maybe like 256, 512 megabyte of RAM, you really, really don't want to be wasting a 30% or 40% or even 25% of RAM to be able to actually run these applications. So Java, the traditional frameworks really aren't made towards this cloud native architecture. That's why Red Hat really came up with Quarkus as a solution, as a way to address this fundamental problem that the Java enterprise architecture had when moving to the microservices world. So schematically, we see in this image is what we had heard from a lot of people from the community, that although they enjoyed Java and they were like really productive with Java, they were moving to other runtimes because they had much smaller footprint. A lot of people moved to Node.js because Node.js was like sort of similar to Java. I mean, they understood the concept, but Node.js application would take up a lot less memory than a regular enterprise Java application. So you see that on the left, this is the traditional cloud native, call it traditional cloud native stack, where you have these big applications. And so in a certain amount of memory, let's say you have a node on a container orchestrator, Kubernetes, or OpenShift. Let's say your node has like, I don't know, let's say 4 gigabyte, right? You could fit a certain only like, let's say 4 instances of an application. With Node.js, you could fit like 8, like the double the amount of the instances of the application. What with Quarkus, since there's been a lot of engineering effort into minimizing the memory footprint, you can take that to even you can deploy a lot more than Node.js, and when you compile down to when Quarkus you compile your Quarkus application down to native using the raw VM technology, then you can get comparable memory footprint to Go. Obviously, everyone knows that Go has great runtime characteristics since it compiles down to native applications, native binary. And with Quarkus, you can retain your great Java productivity, and you can get close to the runtime footprint that a Go application would have. So that's what we see is like the high-level fundamental promise of Quarkus, that you could stay productive in Java, but you can enjoy the benefits of this new cloud native world without having to worry about your containers like running out of memory because the framework is taking up massive amounts of memory. A little bit on the name, because like people wonder like what the name came from. It's basically 2 parts. It's quark, from quark, the elementary particle, and us, which we say is the hardest thing in computer science. That's how the name came about. And let's talk about what benefits Quarkus provides for users, right? We see 4 main benefits, and the first benefit is what we like to call developer joy. So with Quarkus, we want developers to be really, really productive and be able to do things really quickly out of the box and have a great, like, very low configuration experience, be able to reuse all the stuff they already know, basically make it hassle-free as much as possible. and also be able to instantly see their changes when they make source code changes. So in the Java world, people aren't familiar with like what happens in PHP, JavaScript world, where you just make a change, you refresh your browser, you instantly see the changes. So Quarkus makes that work in Java and in Java world with zero hassle. Another thing that, well, like I mentioned before, we place a lot of emphasis on cloud native, right? So what we do here to increase developer joy is that we have a lot of tooling and things that help out the developer to be able to be productive in the cloud native world. So we have like out of the box integration with Kubernetes and OpenShift. I'm gonna demo that in a few minutes, where you can like almost with zero configuration deploy to Kubernetes or OpenShift. You have this remote dev mode where you can deploy your application on to a container, make changes to the source, and have those changes instantly reflected onto the container. Then you have a lot of other great things that make your application able to communicate with all these other cloud native services like in-memory data grids and message brokers and things like that. We have out-of-the-box integration with cloud providers like with Amazon, Google, Microsoft, things like that. With one framework, you can like take advantage of all these cloud providers. We have a serverless framework where you can write your code in Quarkus and it's portable across different cloud providers. So all that really brings, what we really aim to do is bring the joy into development when you use Quarkus. The second benefit we see is what we were talking about earlier about the small footprint. We would like to call this Supersonic, Subatomic Java. Supersonic meaning that it starts really fast, and subatomic meaning that it takes a lot less memory. So really quickly, what this slide here shows is that when you use Quarkus in regular JVM mode, which is middle, it takes about half the memory of a regular cloud native, traditional like Java enterprise stack. And if you use GraalVM, compile down to native image, then comparable to Go. Now the first slide was like, this is like a more real application where you would talk to a database. So again, Quarkus is like at 60% the memory of a traditional Java stack. And if you use in JVM mode, and if you use the GraalVM mode, you're down to like 35 megabyte. Of course, this depends on what kind of CPUs and stuff you run, but the numbers are pretty close to. And this is the startup time. So you see that Quarkus starts really fast, in under a second. And on my machine, it's usually less. It's usually close to 600 milliseconds, but it depends. Where a regular Java stack could take like 4 seconds to start. And of course, if you go to a native mode, then it starts in tens of milliseconds. Same thing if you have to access the database. Easily, Quarkus does under 2 seconds, where a regular application could do around 10 seconds. All this stuff we have on our Quarkus.io website. We have a lot of this. We also encourage users to actually try this out on their own. Really do hold up. Third benefit: a lot of microservice architectures really need to take advantage of reactive patterns and be able to be resilient and really scale as the number of services scale. So what Quarkus does is that it unifies the imperative and reactive programming models. So Quarkus is reactive down to its core, but it's up to the users to actually choose if they want to use reactive APIs or imperative APIs. That's another key focus of Quarkus. I don't have time to like demo that here, but we have a lot of code written to help users out and a lot of documentation to show you how to do that. And the fourth very important benefit of Quarkus is that users that are used to using traditional Java enterprise stacks will feel at home with Quarkus because Quarkus integrates out of the box with so many libraries and frameworks. So people that already know, that have been in the Java enterprise land for years, can just pick up Quarkus and pretty much feel at home and be productive very, 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 very soon. Instead of having to learn everything from scratch and taking time to actually be productive. That's not the case with Quarkus. Quarkus, you should be productive from day one. Okay, so I'm going to go through this one real quick so I can have a demo. So you're probably wondering, like, okay, wow, these startup times are really great. Your memory consumption. What's the magic sauce? Like, what do you do different than most frameworks out there? Well, the answer is that we move as much work that normal Java frameworks do at startup time, we move it to build time. So with Quarkus, there's a lot of extra stuff that happens at build time, which is like parsing configuration files, scanning the Java class path for classes with annotations and stuff, and building all the metadata that frameworks and libraries need in order to run effectively, which they would normally do at runtime. Quarkus does all that at build time. The result is that you save a lot of time by moving all this runtime stuff. You move it into build time. You save a lot of time at startup, plus save a lot of classes. So all the classes that were needed to bootstrap all this metadata are no longer necessary because all of the metadata is pre-populated and ready to go at. So that means like this build time magic means that you start up real fast and you take up a lot less memory. And when we're talking about when we throw in the native application generation into the mix, that means that because native image generation in Java is difficult with raw VM, there's a lot of switches and a lot of things that one needs to do to make it work. With our Quarkus build time process, we can give so many hints to raw VM. Means that building a native image binary out of just makes it just works out of the box for almost everything, all the libraries and frameworks that Quarkus supports. Okay, so I'm going to try and do a demo here. So I think everything should work, at least it did earlier. What I'm going to do is I'm not going to be writing any code. I've pre-created a Quarkus application using our tooling. So there's two ways to create a Quarkus application. You either go to code.quarkus.io or you use our command line tooling to generate a project. I've already done that, so I'm not going to be writing any Java code here. I'm just going to take the project and I'm going to show you how I'm going to deploy it to OpenShift. I have an OpenShift cluster running here. It's still up, great. So I've had this cluster here, and what I'm going to do is that I'm going to show you I added one dependency with Quarkus OpenShift application, and I set just a couple properties to tell me which S2I images to use. And what I'm going to do is, like, with one command, I'm going to build the application, build the binary mode, and I'm going to deploy it to OpenShift using the binary S2I. So I'm launching that now. This will take a couple minutes probably, because it needs to build the Java binary application, and then it needs to initiate the S2I process, the binary S2I process, in order to upload that binary to our cluster. So this is a multifaceted process, but as a user, you don't have to see that. What I'm going to show you here while we're waiting for the application to be deployed is what actually gets created from the Kubernetes manifest point of view. I think actually, these don't get generated until the native application is built. Okay, great. So now it's running the binary S2I process. So what did Quarkus create for us? Quarkus automatically created for us a service account, a service, an image stream, build config, and a deployment and a route. So all this YAML was created automatically from Quarkus using the information that we had configured for the application. So this target port 8080 is the default Quarkus port. If I'd use some other port for Quarkus, then it would just work. It would pick that up out of the box. And also because I'm using health checks, it is added these health checks that it knows Quarkus is using. Quarkus exposes, sorry. So this was all automatically generated, and then once it's generated, it's applied to my cluster. So you saw here that we're deploying the application to the OpenShift cluster. Should be good. Should be done pretty soon. And let's see. It's almost done. So I should have the build config, deployment config up. All right, so that's almost done. And what I see here is that I see my OpenShift cluster starting to deploy the application. And here's the deploy pod. Here's the application that's running, and here are the logs of the application. So this is my Java application that I deployed from my machine to OpenShift. It started in 0.017 seconds, about 17 milliseconds. And it's a Java application. Remember that it's a Java application. And of course, it's exposed as a route. So I'll just say hello, and it returns hello. So that was just the basic. I didn't write any code. This was just pre-generated. So this was just a REST endpoint that returned hello. And that just works out of the box, right? So that you saw the development experience, like the deployment experience to OpenShift is like almost zero. But a lot of folks say, yeah, that's cool, but I want to work with, let's say, vanilla Kubernetes. I love OpenShift, but when I'm developing, I also want to be able to know that I can deploy to vanilla Kubernetes. So in that case, if you're using Minikube, which I'm using here, I'm going to make sure that I use this. I'm going to use the context. I'm going to deploy to Minikube. Okay, so what am I going to do here? I'm going to change this dependency to Minikube, and I'm going to be using Jib to build the. I'm going to be using a Java library called Jib, so you don't need Docker. It's a Java library called Jib that builds it for you. So what I'm going to do now is I'm going to deploy my application to Minishift. So I have Minishift running. Minikube running. Minikube status, so that's running. And I didn't change anything. All I changed basically was the Java dependencies. And now I'm going to deploy it to Minikube. So what this is going to do now is it's going to create this Minikube YAML, which is it's tailor-made towards Minikube. It has the service, it has the deployment, obviously vanilla Kubernetes stuff, and the service in this case is a node port, and Quarkus decides what the port is. The reason we do this is that I'll show you real quick is that it makes it super easy for users to be able to access the service without having to use Ingress. Makes the deployment to Minikube, makes it just work out of the box without like almost any setup from. So what it's doing now is building the container image. So I built the container image into the Docker daemon of the cube. I deployed it. So if I do Minikube list, I think it is. Yeah, and it tells me the URL of the application. I hit it here, and it works. So again, you saw zero configuration almost. Deployed to OpenShift, just worked. Deployed to Minikube, just worked. And with that, I think I'm going to wrap it up my side. And I think that's it for me.
Awesome. Thanks, George. That was great.
Thank you. Thank you.
We do have a couple of questions. One
Great.
is, where can we find information about testing and code coverage?
Okay, so we have a guide. Well, first of all, we have a lot of guides. If you go to quarkus.io site, /guides, we have a bunch of guides, and there's a testing guide in there. Testing your application. So there's, yeah, sorry, yeah. Okay, so can you see my screen now?
Yes.
Great. So there's Quarkus.io/guides, and then there's this getting started testing. But you could find it. There's this from the /guides. You can just search testing your application, and you read the guide, and there's a bunch of information that helps you to be able to easily test your application. So we have integration with the most well-known, most used Java testing framework out there, which is Unifies, which makes testing your Quarkus application a breeze. Obviously, code coverage works out of the box if you properly set it up like you would with any other Java application as well.
Nice.
Yeah, so I think, yeah, you could go through the guide. Also, yeah, I forgot to mention that when you deploy your application, when you can also test both your JVM application and your native application. So that we make it easy for you to test whatever way you want to, whatever mode you want.
And about Thomas, do you want to answer this one? Is this something like a framework? Does this replace a JVM?
So Quarkus can run both on top of a JVM, but it can also run as natively compiled as an application. And it doesn't really replace the JVM, and specifically when we run on top of a JVM, we can perform better in certain use cases, for example. So Quarkus is a framework or an application stack on top of Java or on top of a native build. The fact is that we are today using an upstream project called GraalVM to compile down to native. And when GraalVM compiles down to native, it has something called Substrate VM in it, which emulates all the features we need from a JVM at runtime. So that's the difference between the JVM and the native mode. But Quarkus is an application stack on either JVM or on Substrate VM.
Nice, thanks. And is the deployment YAML generated by Quarkus or Maven?
It's all Quarkus. So the Maven command I executed was the command that actually builds the application. Now, when I passed in this extra flag here, this Quarkus Kubernetes deploy true, that forced Quarkus to create this YAML file and the other ones, the Kubernetes. So you have the option to just generate it, or you can generate it and deploy it to your target cluster. But it's done inside Quarkus as part of the build time things we do.
Yes, and yes, to talk a little bit more about that. The reason we have those functionality in Quarkus is to make it dead easy to move directly from your development environment to something like Kubernetes or OpenShift. And the reason we're doing it is for developers. It's as you progress your application towards production environment, you're probably gonna write these configurations yourself instead, etc. And you'll probably not use them directly from this generated from the tool.
Well, we've got other questions coming in. Let's see. One comment from YouTube, that demo was like magic. So thanks, George. And then another note about the demo, talking about where's the security and where do we set up credentials. You know, that would be a great follow-on another time to get you on to do some like more in-depth demos about how to set those up. What do you think, George?
Yeah, definitely. Yeah, now I've like really blazed through this to try to do both the presentation and the demo. Yeah, there's a lot of stuff we didn't cover here, but this the YAML generation is like very, very configurable. So excuse me?
Oh, go ahead.
Yeah, so there's a ton of stuff you can configure here. Now I accepted most of the defaults to make the demo like do, but there's so much stuff you can do here. And the only prerequisite we have is that in order to deploy to Kubernetes, you need to have to be able, like if you can deploy the application using like kube control apply or OC apply, then we could do it as well, like the basic premise.
Nice. And another question is curious to know whether the JVM params passed to specific to the container -xmx, xms, or -xx use container support. All right, I kind of jumbled out. Which are the
Yeah, no, I think the question is all about. Basically, okay, so when you deploy to Kubernetes, vanilla Kubernetes, you have to do all this stuff yourself, right? We give you the freedom because vanilla Kubernetes like doesn't have a way to determine these. We have a couple things that you can do. We have upstream, like let's say images that can do this for you, like based on its knowledge of the CPUs and the memory that the container has. It can auto tune these parameters for you, or it can allow, or you can as a user, let's say a developer, you can take charge of these parameters and set them yourself. So we don't impose like it has to be a certain parameter, but our upstream images do help with that. Now on OpenShift, when you do S2I, because you use these specific S2I images, all that stuff is usually done for you. So this tuning is usually done for you, but again, you can pass in specific like environment variables or settings to the deployment config and make that tunable as well. Like you can tune it yourself.
Nice. And then one other quick question, and then I asked Thomas to do a walkthrough of something great. How easy or difficult is it to do the instrumentation for tracing and monitoring?
I assume we're talking about like tracing, like open tracing and things like that, right? In that case, like I said, because Quarkus focuses on problems that occur in microservices architectures, and one of the problems is tracing, Quarkus automatically provides a solution for you. So there's an extension. I know what we call an extension is basically like an add-on or something like that. I don't know. Call it. That provides the support out of the box for Quarkus for you. So like I did here in my POM XML, I added the health checks. I would go here and I would add Quarkus open tracing. Yeah, and tracing would be set up automatically for me. It's based on the open tracing Java libraries. So of course that's configurable as well, but out of the box, it'll propagate the headers you need to make requests traceable.
Nice. Okay. So as just a quick segue into, so Thomas, as George mentioned, Thomas is the product manager at Red Hat for Quarkus. Do you cover other things too, Thomas? I guess I should know that answer.
I actually cover a couple of products inside the runtime bundle, as we call it. So I focus on Quarkus, Vertex, and Thorntail. Those are my products that I'm working with. So and that's why you see, I don't know if you see that, but that's why you see the logos of Vertex and Quarkus here as well. But So yeah, so let me see if I can share my screen here and
So I was playing
get
around.
started.
This is a little bit of context as I was playing around with code.quarkus.redhat.com, and I thought this would be great for all of you to
Yeah.
see this walkthrough as well.
So let me, can you see my screen now, by the way?
Yes, thank you.
Perfect. So let me first explain a bit what we do when we because code@quarkus.redhat.com targets what we call the product side of Quarkus, which is actually named Red Hat Build of Quarkus. And the reason we call it Red Hat Build of Quarkus is that we do take builds from the community. We take them through a stabilization phase. We test them and verify them with supported environments like OpenShift and some DVMs and RHEL, etc. And then we're actually building everything from source, and we're building that in, and we productizing Quarkus from that. The output of that is actually a Maven artifact repository. So, but just to show you how to get started with the product and how easy it is. So all you need to do is you need to go to the code.quarkus.redhat.com. And in here you have a simple application that can generate your first project in here. So similar to what Georgios did, but I'm going to do it through this interface now instead. So first you can of course set the Maven artifacts you want to do, and then you can pick the number of extensions here. And extensions, like Georgios said, are things that adds new functionality to the Quarkus application stack. So that could, for example, be open tracing here, and we can select open tracing in here. I'm going to delete that for the moment, but that could also be something like a database driver. So I could, for example, select the H2 database driver. So the H2 database driver, from our perspective, is not something that we support in production. We do support it from development perspective on certain levels, but that's why it's marked with dev support here. So I can select something like that. I could select, so I have access to a database driver. I could, for example, select something like the OpenShift extension. So same thing here, OpenShift extension, it has dev support. Let's also select something that is actually supported. So we can do, for example, Vertex. So if we want reactive behavior, we can add Vertex to our extensions as well. So what this does is basically just indicates to the generator which of these Maven dependencies we should add to the POM file. So when you selected the extensions you want to have, but then you can also see a list of what is fully supported, what is dev supported, if something is tech preview, or if something is deprecated, you can see immediately here and you're aware of what we fully support, etc. But from that, so all I need to do is select download as a zip, and I can save this file. And from that, I'm going to switch over to a terminal. So there is one more step I need to do. And actually, before I do that, I want to point to the product documentation. So if you go to docs.redhat.com, you can see the product documentation. And in there, you can select Red Hat Build of Quarkus. And in here, I'm in a document called Getting Started with Red Hat Build of Quarkus. One of the first thing in here, or early in this section, is you learn how to configure the Maven repository. I mentioned before that when we build it as an enterprise piece, we publish those on the enterprise Maven repository. So we need to tell our system that we're going to use the enterprise Maven repository. So basically, how we do that is the recommended way to do that is to update the settings.xml file in your home M2 directory. And you could also go to activate that profile. So I've already done that. So if we check here, we can see that I have this Enterprise Maven repository, and I also have an early access, by the way. But then the enterprise repository is activated here. So step out of that. I downloaded the application, so let's go and unzip that application that I downloaded. So this is my application, and if I open the pom.xml, similar to what Georgios showed you, we'll see all these dependencies that we added manually before then. We'll see Quarkus, OpenShift, Vertex, etc. And from there, I can go and start my project using, for example, Maven and say Quarkus dev. And this would then start Quarkus in dev mode so that I can change things on live seed and reload, etc. So same function for the product that we have for the community, of course. So that was it for me. Any questions?
So we have a question. Is it stable enough for production workloads? I'm assuming
yes.
Using the tool.
Yeah, so our productized version are always stable enough for production usage. So that's exactly what we go through and verify. At this point, I should mention that the native mode, the one where we're compiling it down to a native executable, it's tech preview, and that will probably go to fully support later this year. But right now, we do only support it on GVM.
Nice. All right. Well, that was the last of the questions, Chris. Unless you have something else from YouTube or from Twitch. Because then I can ask. Sounds good. All right. So are there what other great new features do either of you want to bring up? I mean, now's the time.
Oh, now you're putting us on the spot a bit here.
I know,
so
right?
I think that's good. I mean, another thing I could mention is that the Quarkus community is a fantastic community. It has a lot of external contribution, and it's moving really, really fast ahead. So approximately the pace we're moving at is that we do minor release every month. So a minor release is adding new functionality every month to the product. So in between there, we also have patch releases and other things going out. Worth noticing is that in the community, we only patch the absolute latest version. So you have to stick on the latest version if you're using the community version to get the latest patches and fixes, etc. For the product version, we have a bit more moderate release cadence. So here we release approximately every 6 months. And between there, we'll provide patches, security fixes, and even performance improvements during that period. But feature-wise, I think there's so much coming that I can't really pick one easily. Georgios, do you have anything that you can think about? I think from my perspective, it's gRPC coming and GraphQL support.
Mm-hmm. Yeah. One thing that we don't have yet in product, but we do have in the community version is the command line support. So that was something that a lot of people from the community were asking for, because Quarkus from day one was focused on server, right? But a lot of people saw that Quarkus is so awesome to write applications in. It has such broad, let's say, scope that they wanted to create command line tools. And because it can compile down to native, they were like, wow, this is a great way to create command line tools if they don't know Go, right? A lot of us in the Java community don't know Go, but want to write the native command line. So Quarkus brings that. It's been a month or so. And it should be, in the next product release, Thomas?
Yes.
Yeah. But there's so much stuff, like Thomas said, there's so much stuff I really lose track. I mean, the project by not remembering this stuff, but there's so much stuff that I can't really.
Well, I mean, everything that I've seen upstream and downstream, there's so many great things going on, and it's such a lively community. So that's always good to see, right? That's the sign of a healthy product, a sign of a healthy, application ecosystem, all of that. We do have another question from YouTube. It says, I understand the advantage of startup time and small memory footprint. Is there any performance advantage compared to a normal Java application?
Maybe I should answer that, Georgios.
Yeah.
So we done extensive performance comparison here, and we compared with multiple what we call modern traditional or traditional cloud native runtimes. You can all guess perhaps what that targets, but the point is that what we see is that Quarkus in the JVM will outperform most of the JVM languages out there today. Quarkus on native has much lower memory usage, and that also it's using less resources. So therefore, you might not get the same throughput out of one single container, specifically when you limit the memory. And we also don't really recommend to tune the memory up to a gig of memory just to achieve that. So the JVM's been around for 25 years and just been tuned for that exact use case. Increase the memory to several gigabytes, and we can run extremely fast. So that's what we call vertical scaling, more memory on a particular machine or etc. But Quarkus and native is targeting actually that we can be able to deploy many different containers and can scale the number of containers easily in an orchestrated environment like OpenShift. So what we do with Quarkus native, or how Quarkus native is done, is how we do performance comparison. Is that we compare the number of requests per second that we can get out per megabyte of memory used. So, and if we do that comparison, we haven't seen any of the runtimes out there or other used runtimes that can compare anything closely to what Quarkus native can deliver. So, considering it might. If you consider and compare one single container, it might only give you half the throughput of another JVM-based throughput, but it will use as much as 1/8 of the memory. So you can scale up 8 new containers in that and have the same memory usage that you would for a JVM perspective, and therefore you get a lot more throughput out of something like Quarkus native from that perspective. But Quarkus, as we said, Quarkus works perfectly well on the JVM, and it outperforms a lot on the JVM as well, and specifically when you run it in containers, because that's been kind of the headache. And like Georgios explained in the beginning, a lot of the languages are using so much dynamic lookup and other things, and then you deploy it to a container that is immutable, and it doesn't make sense to have all that dynamic behavior sometimes. And so by optimizing that, Quarkus can really optimize and run faster, both on a JVM and native in a container.
So I had just a thought. Have you seen any use cases start popping out that are just becoming more prevalent? How people are using Quarkus?
You want to start, Georgios?
Yeah, I'll start. Basically, we started seeing people Quarkus really early. I remember a year ago, a colleague of mine and I did a presentation at the conference here in Athens, and some of the folks that were working at Vodafone Greece were so impressed by what they saw from Quarkus that they decided right then, this was a year ago, right? And they decided that they needed to switch from Spring Boot and Vertex to this really new thing then, because they saw the benefits immediately. And so they were one of the first really big organizations that started using this. But I'm sure Thomas will tell you a lot more that as our guides, our blog shows, we have a lot of folks in a lot of organizations, all sorts of sizes, that have started to use Quarkus and are really happy about it.
Yeah, we're starting to see some of the customers also using the possibility to scale down to 0, because specifically on Knative you can scale up from the first request coming in, and Quarkus native is so fast to start that you can actually do that. If you did that and add the overhead of both Knative in itself plus the container plus the Java runtime on top of that, it wouldn't be feasible for a single request to start the container. So you basically need hot containers all the time. But from Quarkus, it's really feasible to do that. We can start really fast, so we can get it starting basically the second that the container is up and running, or in milliseconds from the container is up and running. So that's starting to be a use case that we were seeing customers explore and looking at. And another example of that is deploying to AWS Lambda using native. So AWS Lambda, they kind of, for Java, they try to kind of reuse and rehelp. So they have pools of JVMs running, and then they load your cloud application in and start them up, etc. So they try to do a lot of magic to make it work with the JVM. Nice, and it works, but I saw and one of our customers reported they had startup time still of 6 and 7 seconds before they did it. So they did a Quarkus native application, the same application, compiled it down to natively, deployed it on AWS Lambda, and it started in 400 milliseconds from first request for them. So use cases like that are definitely interesting. I think in the future we're also going to see things like IoT use cases. Upstreams, we are working with the Graal community to enable ARM processes, etc. for native. I think we're going to see more of that. I also think we're going to see more in both data processing and deep learning AI from Quarkus as well.
So lots of exciting stuff. Hey, George, can you put up your slide again with the community info for Quarkus so that everybody can see it once again?
Yes.
And another question, does Quarkus deployment from OpenShift use from scratch, or what base image would we need to create our own container image?
So if you're building the native application, you can basically use just use a standard image like UBI rel 8 or something like that to deploy on. You just add your native on top of UBI 8, and there's no need to install a JVM or anything like that. Depending on your use case, you might need to install additional libraries, but in most cases, it's basically just running on top of UBI directly. Do you have anything to add to that, Georgios? I think.
No, actually, yeah, I think that covers it. Yeah, nothing I can remember.
Yeah, so and from scratch should also work, by the way. That was actually the question, wasn't it?
Yeah, I think we've had users that have reported that they tried that and it worked.
From the product perspective, we prefer UBI 8 though, but Karen, you're muted. I can't hear you. Karina.
Sorry. Would from scratch be supported? It's not the recommended path, but
no, it's not a recommended path. We want to have a secure container that is patched and using the latest versions from RHEL. So from that perspective, we would support-wise, we would focus on RHEL containers and including UBI in that case. And UBI stands for Universal Base Image, if people aren't aware. And the UBI image is really small, isn't it? The minimal is like, I believe it's around 30 megabytes compressed or something like that.
No, we're almost at the top of the hour, so I wanted to ask really fast, are there any virtual events that people should be aware of? Is there, other than joining us again on this channel when we do a deeper dive?
Not on top of my head.
Well, the Dev Nation has a lot of stuff, Quarkus and Kubernetes. The Red Hat developer channel has a lot of stuff going on. So definitely check out that. They have master classes for various aspects of Quarkus.
Nice.
Yeah.
So Google Dev Nation.
And follow us on Twitter, and we will post things where Quarkus is is happening. I know there are a bunch of workshops planned from the Red Hat team as well. So go check out developers.redhat.com as well. I believe you'll find the information about workshops and other things. Oh yeah, actually one resource I remember now, sorry, we're out of time soon. But actually there are some really good getting started examples as well. If you go to learn.openshift.com, so learn.openshift.com is a sandbox environment where you get a small editor and you can do some changes, etc. And in here, if you go to build applications on OpenShift, it's build application on OpenShift is one of the boxes.
Oh,
There. And here
right.
you're developing with Quarkus, and we have something like 5 or 6 courses there showing different use cases, like adding a database driver, adding reactive database access, etc.
Nice, nice, really nice.
Perfect. Yeah, thanks for sharing those.
Yeah,
Those are
and then
great
you have
resources.
more info about monitoring and monitoring with Prometheus and Grafana as well.
Mhm.
Check out. Okay.
All right,
Thanks.
thank you. And I think another follow-up session that might be interesting is serverless with Quarkus.
Yes, absolutely.
So we may be having lots of Quarkus sessions coming up soon.
That'll make us happy.
Make us happy too. And by the way, as Chris mentioned, there's lots of thanks from everybody for doing this, YouTube and Twitch, and so thank you both. It's been great. So,
Thank you.
And thanks.
Thanks for having us, and thanks for everyone for watching.
Yes.
Yeah, thank you. Thank you so much. Thanks from all around, all the social networks here.
Okay. Bye.
Thanks, everybody.
Thanks.
Bye.
Bye.
Bye-bye.
Recording has stopped.
Still working out the ending.